In this problem, we're trying to determine the number of customers waiting in line for a ski lift at Copper Mountain. Now we know from historical evidence the probabilities of between the chairs passing the lift of there being no customers arriving or no skiers arriving, one skier arriving and two skier arriving. And that's given by A1 and A2 and A3. And looking at this state transition diagram, we can see that A1 corresponds to the probability of two customers arriving, A2 corresponds to the probability of no customers arriving, and A3 corresponds to the probability of one customer arriving, or one skier arriving. And keep in mind that 0, 1, 2, 3, and 4, those are the number of people waiting in line. And so if there is a skier waiting, he's going to get on the chair, and then we look at the number of people waiting in line immediately after that. As was shown in the problem video, the probability generating function for this discrete time Markov chain that has an infinite state space can be shown to be as follows. And that reduces to this expression here. And notice that in this expression we have a pi 0 that we need to get rid of. Well, we know by identity that p of 1 is equal to 1. That is, the probabilities must sum to 1. And again, keep in mind the probability generating function is just a series expansion of the probability mass function. So if I put in s is equal to 1, those probabilities must sum to 1. From this identity, I can put that into here, and I get that pi 0 is equal to 1 minus A1 over A2, where A1 and A2, again, correspond to the probability of two arrivals or no arrivals between passes of the lift. And pi 0 is the probability of no customers waiting in line. So now we take this and we plug it into, for the regular speed lift, we have the following probabilities, and for the high speed lift, we have the following probabilities. For the regular speed lift, the probability of no customers waiting is 0.33, and for the high speed lift, the probability of no customers waiting is 0.571, and again, we get that from this expression here. We then want to get the probability of there being one customer waiting and the probability of there being two customers waiting, which we can get through differentiating this probability generating function and evaluating at s is equal to 0 as follows. In particular, it's 1 over n factorial times the nth derivative of that probability generating function evaluated at s is equal to 0. And we can also get the expectation by taking the derivative evaluated at s equal to 1. So for these two cases, when we do that, we get the probability of one customer being 0.22, two customers being 1.48, and the expected number of customers waiting in line at the lift as being 2. And over here we have 0.571, 0.244, 0.105, and the expected number of customers waiting in line is 0.75. So in making a decision about whether or not they should put in a high-speed chair, Copper Mountain can look at these probabilities, and they could look at more probabilities if they wanted to. And they could see that the expected number of customers would go down from 2 to 0.75. The probability of nobody waiting would go up from 0.33 to 0.571, and so forth.